Hey there, welcome to today's lesson on section 9.5. This will be our first video in quite a while. So in this section we're going to talk about hyperbolas, which will be the last type of graph that we'll discuss in this chapter. And then we're going to start moving things away from 0, 0, like moving the center away from 0, 0, and also solving systems of nonlinear equations. But before we do that, we need to talk about this last type of graph. It's called hyperbolas, not hyperbole, which you guys learned in English class. That's an extreme exaggeration. No, but hyperbolas. So we'll start with the Euclidean definition of hyperbola, like we've done for parabolas, circles, and ellipses. Hyperbola is the set of all points in which, now in this case, the difference, not the sum, before was the sum for the ellipse, but for the hyperbola is in which the difference of the distances from two fixed points is a constant. The two fixed points are called, as usual, the foci. So let me draw a picture for a particular hyperbola for you guys. Here would be the equation. X squared over a squared minus y squared over b squared equals 1. The center, we'll keep it at 0, 0. That'd be a, that'd be negative a. Here's your center. And essentially it's going to look like two parabolas that are going away from each other. If x squared or probably a better way of saying this, if fraction containing x squared is positive, the hyperbola opens horizontally. So in this case, we say that the vertices are at plus or minus a comma 0. The transverse axis, which is like axis of symmetry, is horizontal, or in this case, y equals 0. And then for the foci, this will be a little tricky. We'll say plus minus c comma 0. It's always on the transverse axis. They'll be located right here. So this would be one focus, this would be the other focus. And that is c, and that would be negative c. So you probably think to yourself, well, where is b going to be? Essentially, b will be somewhere on the y-axis for this type of graph. And what you do is that you imagine there's a box. And the imaginary box is used to generate the graph. There also is going to be two asymptotes. is basically going to be the diagonals through the box. So it'll be diagonals through the box. And those equations will be y equals plus or minus b over a times x. Because if you think about it, the slope is rise over run. It goes up to b and it runs to wherever a is. And of course you can go down and go to wherever a is because you have another asymptote that has a negative slope. So that explains the plus or minus. To find the foci, instead of c squared equals a squared minus b squared, it's now c squared equals a squared plus b squared. That will allow us to get the focus, or the foci. So, to summarize, if you have x squared over a squared minus y squared over b squared equals 1, that will represent a hyperbola with a horizontal transverse axis. The vertices will be on the x-axis, so plus minus a comma 0, and your asymptotes will be this. If you reverse x squared and y squared, so now the fraction contains y squared is positive, this will be your equation. It will be a vertical transverse axis. Vertices will be on the y-axis, and their asymptotes will be plus or minus a over b times x. A squared always below term of transverse axis is located. So in this case, because we have horizontal transverse axis, a squared is below x squared. In this case, if we have vertical transverse axis, a squared is below y squared. So it's always going to be with the fraction that's positive. So let's try a few examples. So we'll start with number 1. Now, first step is to write in standard form. Standard form always requires us to get 1 on the right side. So I divide both sides by 100. Divide that by 100. Divide that by 100. And divide that by 100. So you have y squared over 4 minus x squared over 25 equals 1. Second step, locate a and b. So a squared equals 4, so clearly a equals plus or minus 2. B squared equals 25, so B is going to be plus or minus 5. Third step, plot A and B to generate a box. And draw in the diagonals. So we're going to have a rectangle that we're going to draw. So let's see here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now in this case, A is going to go with Y, and B is going to go with X. That's because A squared is beneath Y squared, and B squared is beneath X squared. So changing colors up, I'm going to locate 2 and negative 2 on the y-axis, and 5 and negative 5 on the x-axis. Now we draw a box. Usually I like to use dashed lines. And draw on your diagonals. And because y squared is positive, so now the fourth step is graph the hyperbola. Since y squared fraction is positive, it opens vertically. So you use the asymptotes and use the box to guide your graph. That's the whole purpose of having that. So here we have the graph. And then the fifth step, state the vertices, the foci, and the asymptotes. Well, that should be easy. V is going to be 0, plus minus 2. The foci, if we calculate it, c squared equals a squared plus b squared. C squared is going to equal 29. So c equals root 29. So in this case, we say 0, plus or minus root 29. So it's actually going to be here and here. And then finally for your asymptotes, that will be y equals, now in this case we said plus or minus a over b, because it's a vertical transverse axis. So we'll say plus or minus 2/5. And you can just tell it goes up 2 over 5 and also down 2 over 5. So clearly you have a chance to practice stuff when we meet again tomorrow or Wednesday for G period. And the last problem, write the equation of hyperbolas vertices plus minus 4, 0 and foci at plus minus 3, 0. This is example 2 on page 643. So usually what I like to do is make a quick sketch as a first step. So let's see here, 1, 2, 3, 4. 1, 2, 3, 4. So they're my vertices. My foci. Oh, oops, I had these mixed up. My apologies. Your foci are plus minus 4, 0, and your vertices. So sorry for the typo. The vertices are plus minus 3, 0. So let me erase this graph here. Alright. So vertices are plus minus 3, 0. And here are your foci. So the graph looks roughly like this. So it's pretty obvious there's a horizontal transverse axis. It's kind of like the axis of symmetry. So we're going to have to go with this equation. So that's the second step. Which equation to use? X squared over a squared minus y squared over b squared equals 1. And then third step, find a and b. Well, a is going to be easy. That's going to be 3 because that's going to represent our vertices. A is always for the vertices, just like the ellipses. For b, remember c squared equals a squared plus b squared. And we know c equals 4 due to the focus. So 16 equals 9 plus b squared. B squared is going to equal 7. So b is root 7. So the equation should be easy. X squared over 9 minus y squared over 7 equals 1. And that's it. That's today's video on 9.5. We will do more problems like this in class when we meet again during block number 1 this week. Okay, goodbye.